Our cosmic backyard is vast. It's filled with celestial wonders. From our small planet, we gaze up at the night sky in awe. We can see stars, planets, and the faint glow of distant galaxies. This is our universe. It's a place of incredible size, beauty, and mystery. For centuries, humans have pondered the cosmos. We've asked big questions. How big is the universe? What is it made of? Are we alone? Today, science is giving us new ways to answer these questions. We are living in a golden age of astronomical discovery. Through powerful telescopes and sophisticated instruments, we're peering deeper into space than ever before. We're uncovering the secrets of the universe. We're also grappling with new mysteries. The more we learn, the more we realize how much we don't know. Join me on a journey through the cosmos. We'll explore the wonders of the universe together. Get ready to be amazed. The universe is full of surprises. The universe is vast. It's also incredibly well organized, a cosmic masterpiece that stretches beyond our wildest imaginations. The universe is built on a vast cosmic web, an intricate network that connects everything. This web is made up of galaxies, gas, and dark matter, all interwoven in a delicate balance. Imagine a spider web that stretches across unimaginable distances, linking countless celestial bodies. That's the basic structure of our universe, a grand tapestry of interconnected elements. At the smallest level, we have atoms, the fundamental building blocks of all matter. Atoms are incredibly tiny, yet they form the foundation of everything we see and touch. Yet they are made up of even smaller particles called protons, neutrons, and electrons, each playing a crucial role. It's hard to grasp the sheer scale of the very small, where the laws of physics operate in fascinating ways. Zooming out, we encounter stars, the luminous giants of the cosmos. Stars are giant balls of hot gas, burning brightly in the vast expanse of space. They generate energy through nuclear fusion, a process that powers their incredible light and heat. Our sun is a star, a relatively average one in the grand scheme of the universe. It's just one of billions in our galaxy, the Milky Way, a vast collection of stars and other celestial objects. Galaxies are vast collections of stars, gas, dust, and dark matter, each with its own unique characteristics. They come in many shapes and sizes, from spirals to ellipticals to irregular forms. Some are spirals, like our own Milky Way, with beautiful winding arms. Others are elliptical or irregular, each type contributing to the diversity of the universe. Galaxies are grouped into clusters, massive gatherings of galaxies bound by gravity. These clusters are then grouped into superclusters, forming even larger structures. The largest structures in the universe are galaxy filaments, immense threads of galaxies. These are vast chains of galaxy clusters, stretching across the cosmos. They stretch for hundreds of millions of light years, connecting different parts of the universe. These filaments are connected by cosmic voids, vast empty spaces that separate the filaments. These voids are relatively empty regions of space, highlighting the contrast between the dense filaments and the sparse voids. Stars are the fundamental building blocks of galaxies. They are born in giant clouds of gas and dust called nebulae. Imagine a cosmic nursery where stars first ignite. Nebulae are some of the most beautiful and awe-inspiring sights in the universe. The Orion Nebula is a famous example. It's visible to the naked eye. Inside the Orion Nebula, gravity pulls gas and dust together. These clumps of matter heat up. Eventually, they ignite as new stars. Galaxies are collections of stars, gas, dust, and dark matter. They come in a variety of shapes and sizes. Spiral galaxies, like our own Milky Way, have arms of stars, gas, and dust that spiral outward from a central bulge. Elliptical galaxies are smooth and oval-shaped. Irregular galaxies have no defined shape. Galaxies are not randomly scattered throughout the universe. They are organized into groups called clusters. These clusters are then grouped into even larger structures called superclusters. The Milky Way is part of the Local Group, a cluster of about 54 galaxies. Section 4, Cosmic Abyss, delving into black holes. Black holes are among the most fascinating and mysterious objects in the universe. They captivate the imagination of scientists and enthusiasts alike, drawing us into their enigmatic nature. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull warps the fabric of space and time, creating a cosmic trap. Black holes form when massive stars collapse at the end of their lives. This cataclysmic event, often marked by a supernova explosion, compresses the star's core into an incredibly dense state. Imagine the entire mass of a star squeezed into a tiny point. This point, known as a singularity, is where the laws of physics as we know them break down. This creates a region of infinite density and zero volume, known as a singularity. The singularity is a place where our understanding of the universe ceases to function normally. The singularity of a black hole is surrounded by an event horizon. This boundary marks the limits of the black hole's influence. This is the point of no return. Once an object crosses this threshold, it is irrevocably drawn into the black hole. Once something crosses the event horizon, it can never escape the black hole's gravitational pull. The immense force ensures that anything within this boundary is lost to the depths of the black hole. Not even light can escape. This is why black holes appear black, as they do not emit any light that we can see. Black holes are invisible to telescopes that detect light, X-rays, or other forms of electromagnetic radiation. Their presence is inferred through their gravitational effects on surrounding matter. However, we can detect them indirectly by observing their effects on nearby matter. For instance, gas and dust spiraling into a black hole form an accretion disk which emits intense radiation. For example, as gas falls into a black hole, it heats up and emits X-rays that we can detect. These X-rays provide crucial clues about the black hole's presence and properties. Supermassive black holes are thought to exist at the centers of most galaxies, including our own Milky Way. These colossal entities anchor the galaxies around them. These behemoths can have masses millions or even billions of times greater than the Sun. Their immense size and mass make them key players in the cosmic landscape. They play a crucial role in the evolution of galaxies. By influencing the motion of stars and gas, supermassive black holes help shape the structure and dynamics of their host galaxies. Section 5. Echoes of the Big Bang Cosmic Microwave Background Radiation. The cosmic microwave background, or CMB, is a faint afterglow of the Big Bang. It's a snapshot of the universe as it was just 380,000 years after its birth. It's everywhere in the universe. Imagine the universe filled with a sea of hot, dense gas. As the universe expanded and cooled, this gas became less dense and more transparent. Eventually, light was able to travel freely through the universe. The CMB is the oldest light we can see. It has been traveling through the universe for over 13 billion years. It provides us with a wealth of information about the early universe. The CMB is remarkably uniform in all directions. However, it also contains tiny temperature fluctuations. These fluctuations provide clues about the seeds that would eventually grow into galaxies and other large-scale structures. Section 6. Stellar fireworks, supernovae, and the cycle of stars. Stars are not eternal. They have a life cycle that is both fascinating and complex. They are born from clouds of gas and dust. They live for millions to billions of years, and eventually they die. The death of a star can be a spectacular event, often more dramatic than its birth. It can be just as awe-inspiring as its birth, marking the end of one stellar life and the beginning of another. Massive stars end their lives in gigantic explosions called supernovae, which are among the most powerful events in the cosmos. These explosions are among the most energetic events in the universe, releasing more energy in a few seconds than our Sun will in its entire lifetime. They can outshine entire galaxies for a brief period, making them visible across vast distances in space. Supernovae occur when a star runs out of fuel in its core, leading to a catastrophic collapse. The core collapses under its own gravity, triggering a shockwave that rips the star apart in a brilliant explosion. The explosion scatters the star's outer layers into space, creating a beautiful and chaotic scene. These remnants can eventually form new stars and planets, continuing the cycle of stellar evolution. Supernovae play a crucial role in the evolution of the universe, influencing the formation of galaxies and the distribution of elements. They are the primary source of heavy elements such as oxygen, carbon, and iron, which are essential for the formation of planets and life. These elements are essential for life as we know it, making supernova a key player in the cosmic story of life. The Crab Nebula is a famous example of a supernova remnant, showcasing the aftermath of a stellar explosion. It's the result of a supernova that was observed by Chinese astronomers in 1054 AD. a historical event that has been studied for centuries. The nebula is still expanding today, a dynamic and ever-changing structure in the cosmos. It's a testament to the power of these cosmic explosions, reminding us of the incredible forces at work in the universe. Section 7. Galactic beacons, quasars, and active galaxies. Quasars are among the most luminous objects in the universe. They are powered by supermassive black holes at the centers of distant galaxies. They shine brightly across vast cosmic distances. As gas falls into a supermassive black hole, it heats up and emits intense radiation. This radiation can be detected across billions of light years. This is what makes quasars visible to us. Quasars are thought to be early stages in the evolution of galaxies. They were more common in the early universe, and this is because galaxies were closer together and collisions were more frequent. Active galaxies are galaxies that emit unusually large amounts of energy from their cores. This energy is thought to be powered by supermassive black holes. Quasars are a type of active galaxy. Active galaxies play an important role in the evolution of the universe. They influence the formation of stars and galaxies. They also contribute to the intergalactic medium, the gas and dust that exists between galaxies.
Like and subscribe to start your journey today.